Okay, here's your second question. It's really quick. So you had 325 domesticated cats. Full color is the dominant gene, big D, 194. 131 cats. That's the recessive one. So what we're going to do is the same thing we did before. We're not going to focus on the full one because the full phenotype that we see in our cats will contain both the dominant and the heterozygous, like the homozygous dominant and the heterozygous cats. So we're going to focus with the recessive ones. So we know that q squared is going to be 131 out of 325. Q squared equals 0.403. Take the square root of both sides. Q equals 0.635. In this case, Q is the same thing as this recessive allele, so this would be your first box. The second question asks you to estimate how many of the 194 are heterozygotes. So we're trying to figure out, of the 194 full color, we're trying to figure out how many are heterozygotes. How many are big D, little d? Because we don't know what that breakdown is. But the way you figure that out, the frequency of heterozygotes is 2pq. So next we'll find p. P is equal to 1 minus q. 1 minus 0.403 equals... Oh, I'm sorry, that's not what I meant. It's supposed to be 0.635. We get 0.365. And so now since we found P, we can find the heterozygous frequency. So 2pq equals 2 times 0.365 times 0.635. And so this is the frequency. This is frequency of big D, little d of entire population. So what I'm going to do is take 2pq and multiply it by the entire population. Right? So this is going to be 2 times 0.365 times 0.635 times 325. And that gives us 150.6. So that's approximately 151, which is the second answer. This is the number you expect to see. 151. Of big D, little d. So hopefully that helps.